In my experience, what we hear from the customers that we serve is that they're looking for ways to save money.
We're seeing a big trend in people either trying to reduce their carbon footprint or reduce their energy costs. Everybody's really looking at the bottom line.
Welcome, welcome, welcome to PSG's live streaming event. Today we are introducing Wilden's Pro-Flo SHIFT, a revolutionary air distribution system technology that we feel will change the game of air-operated double diaphragm pumps. I'd like to thank you for taking time out of your day to spend an hour with us to learn about the Pro-Flo SHIFT. My name is Walter Bonet and I am the Vice President for PSG Marketing. And today, I want to give you a brief overview of the hour. We're going to introduce PSG and Wilden, give you a brief overview, I promise, just a small overview. And we will introduce you to the technology, and then we will do a live demonstration of the Pro-Flo SHIFT. Also note, we have a chat room, and you can ask any questions, and we will do our best to answer all of them. And we will answer your question towards the end of the live demonstration. So, a little brief overview on PSG. PSG Pump Solutions Group is part of Dover. Dover is a Fortune 500 company. We have 1,700 employees around the world. PSG is recognized as a global leader in positive displacement and pumps and systems technology. You can find any of our pumps across a multitude of markets: oil and gas, hygienic, and chemical, to name a few. We have world-class brands, many of you know already, such as Blackmer, Wilden, Almatec, and Mog, to name a few. Typically, we have all of our operations around the world practice lean manufacturing and offer best-in-class operations. And we have a global footprint where you can find PSG facilities across the world in Germany, France, India, China, Australia, to name a few countries. And we are doing business in over 100 countries worldwide. A little bit about Wilden. Wilden was founded in 1955 by James K. Wilden, who invented the air-operated double diaphragm pump. And in fact, innovation, which is in part what we're going to talk about today, is in the DNA of Wilden. As you can see with the slide, Wilden has many accomplishments and is first in many of its innovation, first to introduce the air-operated double diaphragm pump, plastic pumps, to offer Teflon or PTFE diaphragms to the market, and to introduce advanced ADSs such as Pro-Flo, Pro-Flo X, and today we will introduce the Pro-Flo SHIFT. Wilden became part of the Pump Solutions Group in 2008, and we are happy to be part of Dover and the Pump Solutions Group. Little overview on Wilden. We are an innovative leader, constantly moving forward the industry, advancing our technologies, and pressing forward to enhance our customers' value propositions. You can find Wilden around the world, as we're a very global company, where 55% of our sales are global. We have the largest breadth of pump sizes and material offering, anywhere from a 1/4-inch pump all the way through a 4-inch pump in multiple materials and diaphragm options. We offer the air-operated double diaphragm in both bolted and clamped options. And again, innovation is in our DNA, and we've introduced world-class air distribution system throughout our history with Pro-Flo, Pro-Flo X, and now Pro-Flo SHIFT. And lastly, you can find a Wilden pump, a very robust utilitarian technology where you can find a Wilden 2 miles deep in a mine of Chile in a dewatering application, all the way through in a pharmaceutical application transferring eye contact lens solution. So before we get started, I'd like to introduce the Pro-Flo SHIFT in a lab test video that we have for you to show you the Pro-Flo SHIFT in action against the competition, and to give you some of the benefits and value proposition of the Pro-Flo SHIFT.
Since the invention of the pneumatic pump, customers have had one consistent concern.
In my experience, what we hear from the customers that we serve is that they're looking for ways to save money.
We're seeing a big trend in people either trying to reduce their carbon footprint or reduce their energy costs. Everybody's really looking at the bottom line.
The time has come to set a new standard. With an innovation so simple yet so effective, it can cut air consumption by more than 50%. The time has come to shift your thinking. Introducing Wilden's new Pro-Flo SHIFT. We put some of the best AODD pumps to the test. In carefully controlled side-by-side laboratory trials, we showed an experienced group of pump experts exactly how Wilden's new Pro-Flo SHIFT technology performs under a variety of set conditions. In each test, the head pressure was set exactly the same. The variable, the air consumption required to achieve a set flow rate. We even piped the Pro-Flo SHIFT at the end of the test rack to make it work just a little harder than the others. Performance comparisons to standard AODD pumps were dramatic. The amount of air required to achieve the same flow rate was about half for Pro-Flo SHIFT. And against some of the perceived leaders in air efficiency, Wilden's Pro-Flo SHIFT still came out on top.
Wow.
But there are other differences beyond the reduced air consumption. Differences that require a shift in the way industry thinks about AODD pumps. Part of the beauty of Wilden's Pro-Flo SHIFT is the simplicity. There's no learning, no electronics, making Pro-Flo SHIFT submersible. Just one simple part shifts the entire process. No more overfilling in the pumping chamber. No need for complicated flow curves to set it up. The results are in, and the data speaks for itself. Pro-Flo SHIFT will change the way we think about air-driven pumps. Industry experts agree.
You know, to kind of look at that, I mean, simplicity of coming up with something that does this without all the bells and whistles and the weight of it and the cost of it. Something simple as that, to look at the efficiency advantage. It's, you know, amazing.
Pro-Flo SHIFT is the greatest innovation that I've seen in diaphragm pumps in my career.
From the company that bears the name of the man who invented air-operated double diaphragm pumps, comes a new innovation that will change the game. This is the most energy-efficient AODD pump ever produced. Simple, reliable, efficient. The new Wilden Pro-Flo SHIFT. Shift your thinking. Make the shift to Wilden's new PS line of high-efficiency pumps.
PSG, where innovation flows.
As you just witnessed, the Pro-Flo SHIFT offers a compelling story, a unique value proposition that the SHIFT brings to the industry and to our customers. With that, I'd like to introduce Mr. Greg Duncan, the Wilden's Director of Business Development. Greg?
Thank you, Walter. Welcome, and I'd like to thank you for joining us today. In my role at Wilden, for more than 20 years, I've been involved with the development and improvement of air distribution systems. And I have to tell you, the Pro-Flo SHIFT is one of the most exciting and interesting innovations that I've seen in this area. We've been testing the technology for many months to ensure that it provides flawless performance when it reaches the hands of the customers, and also to ensure that it delivers the value that customers have come to expect from the Wilden brand. And I'm pleased to tell you the results are in now, and in fact, the product has actually outperformed our expectations. So we've got some great things in store to show you today. We believe that with this new technology, we're really positioned to lead the market, not just with efficiency, but also with market-leading performance and the simplicity and reliability that have really become hallmarks of the Wilden brand. Before I get into the details, I'd like to show you another brief video to show you how the technology actually works.
For traditional air-operated double diaphragm pumps, the air distribution system functions by filling the air chamber or diaphragm cavity with as much air as available, essentially overfilling the air chamber until the end of the stroke, thus displacing fluid on the wetted side of the diaphragm. Once the shaft and diaphragms have reached the end of their stroke, a mechanical mechanism triggers the end of the stroke, finally shutting off the air supply to that air chamber, signaling the air valve to shift and dump any excess air left in the filling air chamber. This position also starts filling the opposing air chamber to start the reciprocal motion and the start of another pumping cycle. Pro-Flo SHIFT technology is designed to maximize efficiency by minimizing air consumption. This new technology optimizes the pump's performance by using the position-sensitive air control spool, which automatically meters air at the end of the stroke, preventing overcharging or overfilling of the air chamber without any loss of performance or product yield or flow. Pro-Flo SHIFT's automated technology results in significant air savings over conventional and advanced AODDP technologies. Pro-Flo SHIFT saves you money and increases plant profitability without the need for electronic components, difficult to read curves, or additional configuration. It is truly as easy as plug, pump, and save. It takes a shift to move an industry. Simple, reliable, efficient. Shift your thinking with Wilden's Pro-Flo SHIFT.
Now that you've seen an overview of how the technology works, I'd like to get into a little more depth because I know this is a technical audience. What you see before you is a diagram showing the pressures inside a diaphragm pump as it operates. And what you can see there on the left side of the screen is a diaphragm pump liquid chamber and air chamber on its output stroke. The red pressure trace indicates the pressures inside the liquid chamber, while the green pressure trace indicates the pressures inside the air chamber. You can see as the pump discharges liquid, there's a constant output pressure generated in the liquid chamber. And once the pump reaches the end of the stroke, the pressure drops off. What you don't see in this chart is a corresponding pressure increase on the opposite chamber. What's interesting to note in this chart here is as the pressure drops off, you'll notice an increase in the pressure in the air chamber at the same time. And what causes this is a slight delay between the signal that indicates that the air valve should shift and the actual shift taking place. During this time, the air valve allows the air to flow unimpeded into the air chamber, even though it's not possible to do any additional work since the pump is at the end of its pumping stroke. Therefore, the pressure in the air chamber increases, and any air that enters at that point is simply wasted air and ultimately wasted energy. Our engineers observed this phenomena and identified it as an opportunity to provide an improvement to the product. And the results of their efforts is the Pro-Flo SHIFT technology. The heart of this technology is the air control spool, which is an additional valve installed in the center portion of the pump, whose job is to meter and control the flow of air into the air chamber. This valve actually works during each pump stroke. At the beginning of the stroke, the valve is positioned such that air can flow unimpeded into the air chamber, energizing the diaphragm and doing the work of moving the fluid. At the end of the stroke, the valve is actuated and it begins to control and reduce the flow of air into the air chamber to prevent that overfilling or overcharging phenomena. But in fact, there's an additional benefit to be gained from this valve. It actually activates somewhat before the end of the stroke, trapping the bulk of the air in the air chamber and causing it to do additional work without replenishment from the air source, further enhancing the efficiency of the technology. So the results here are shown in a similar diagram for the Pro-Flo SHIFT technology. You can see that at the end of the stroke, instead of that typical pressure increase, you actually see a pressure decrease, which not only shows that the overfilling is not occurring, but also shows you that the air in the air chamber is performing additional work. But of course, this is not all about reducing the compressed air of the pump. This is actually about reducing the amount of energy that the pump used and ultimately saving the customer money. So what you can see here is the equation where you can calculate the actual horsepower consumed by an air-powered device. And you can see that it's really comprised of two variables, the air flow to the pump and also the pressure that that air is supplied at. This can be a little confusing when trying to compare two pieces of equipment because there's multiple variables to consider. However, in the real world, a customer's air plant system is comprised of a set of compressors and storage tanks that really supply the same pressure throughout the plant. So in essence, in a real-world scenario in a factory, when a customer is interchanging one piece of air-powered equipment for another, the pressure doesn't change. The pressure is the compressed air system pressure throughout the plant. So when you're really comparing two different pieces of equipment, all you really need to look at is the SCFM, or the cubic feet of air that that piece of equipment is consuming. So when you take that into account for the Pro-Flo Shift, it makes it very simple to compare two pumps to one another. What we have here is a chart illustrating multiple competitive technologies and the Pro-Flo Shift at various operating conditions. Each group of bars in the chart represents a particular flow rate as shown by the number below the group. We've got 40 GPM, 77, 95, and on up across the performance range of the pump. And essentially on the y-axis, you can see the compressed air consumption of each device. So essentially, the device with the shortest bar is the one that is consuming the least energy. And as you can see, throughout the performance envelope, compared to a wide range of market-leading competitors, the Pro-Flo Shift clearly beats them hands down, in some cases using half the compressed air of the competition. Clearly, this is a tremendous value that you can provide to a customer. Many customers have not just one or two pumps, but 10 or 20 or even 100 pumps in a plant. And you're talking potential savings that could be really significant. I want to show you how we generated this data in a head-to-head testing video. And you can see exactly how we've positioned these pumps to perform the same output and capture the energy that's consumed.
Competitive tests compare Wilden's Pro-Flo Shift with a 2-inch Aero EXP series AOD pump. The condition of service was set by starting each pump and adjusting the fluid ball valve and air pressure regulator to achieve a specific fluid pressure drop and fluid flow rate. This would mimic a real-life dynamic head condition with fluid flow rate requirements. The Wilden Pro-Flo Shift was even piped at the end of a test skid full of competitive pumps to make the pipe run a little longer than the others. Same hose length, head-to-head, no gimmicks. A simple scientific test in front of a room full of engineers and pump experts. The new Pro-Flo Shift air distribution system compared to a well-known brand with a standard ADS. After each competitor met the set conditions, the only variable in the test was the air consumption, as measured in SCFM, needed to produce the same flow rate. The results were dramatically clear. Pro-Flo Shift required much less SCFM to generate the same flow rate. Thanks to the revolutionary yet simple air valve system, the Pro-Flo Shift delivers precise flow rates instantly, head-to-head against 8 different competitors. Pro-Flo Shift uses less air, which means less energy consumption and more output with your compressor capacity. Simple, reliable, efficient. This is the most revolutionary innovation in air-operated double diaphragm pumps since Jim Wilden invented AODD technology. Wilden's Pro-Flo Shift, the most energy-efficient AODD pump ever produced. Shift your thinking. Make the shift to Wilden's PS line of high-efficiency pumps.
PSG, where innovation flows.
As you can see, the Pro-Flo Shift presents a compelling argument for operational performance, energy savings, reducing carbon footprint for our customers, and really increasing our customers' operational profitability within their applications by simply reducing air consumption and increasing performance. We are very excited about this product, and we would like to now move to the live demonstration with the skid here. Let me introduce Mr. Carl Glauber, the inventor of the Wilden Pro-Flo SHIFT. Gentlemen.
Thank you, Walter. Welcome, everyone. Thank you for attending. What you're looking at here is our self-contained, fully functional, competitive test skid. And on this skid, we have traditional, advanced, air-operated double diaphragm pumps, aluminum construction with Wilflex elastomers or Santoprene elastomers. In the front of the skid, we have Versamatic, we have Graco, we have Yamada, we have Sandpiper, and we have Aero, the Expert series. These are all the traditional designs. As we move towards the back of the skid, we have the advanced technology, which is the Air Advantage Sandpiper, the Air Advantage Versamatic. We also, at the very end of the skid, have the current Wilden Pro-Flo X and the new Pro-Flo SHIFT design.
Thanks, Carl. Can you tell them a little bit about the equipment on the test skid and how we've set up the tests so the pumps are actually producing the same output for comparison purposes?
Sure. What we have done, the skid contains basically three components. One is the compressed air, the second is the fluid transfer, and the third is the data acquisition. And if you look at each pump, you'll see each pump is mounted with a pressure transducer on the air side and also a pressure transducer on the fluid side, separated by a diaphragm. So as the pump is stroking back and forth, we'll be able to capture the pressure that the pump is putting out and visibly see it on the monitor.
So you'll be able to see what's happening inside the pump in real time.
Yes, during each stroke. And then from the air component, we have the compressed air coming into the system right here, goes through a flow meter, then through a pressure regulator, and then down out of the pressure regulator into the pump. It's worth noting that our air compressor begins to make compressed air at 135 pounds of pressure and then stops making air or unloads at 145 pounds of pressure. So as Greg mentioned previously, we begin to burn the energy or make the compressed air at 135 pounds. So anything that operates below 135 pounds really isn't affecting our dollar volume.
So what you're trying to say here is, no matter how you set this regulator, the PSI value in the horsepower calculation really isn't the number on this gauge. It's really the set point of the compressor.
Right. For the money standpoint, we start to spend money at 135 pounds. The next component is the fluid transfer. And what we have is a 200-gallon reservoir here filled up with water. Out of the bottom of the reservoir, we come into a suction manifold that runs the full length of the pipe. There is a flow meter at the beginning of the pipe. The output of the flow meter in gallons per minute is seen right here. Each pump is valved off. As we come through a particular pump, we'll come into a discharge manifold. Down through the discharge manifold, we'll come into a fluid pressure gauge, and then through a throttling valve and back into the reservoir.
So essentially what we have reproduced here is a closed-loop performance test setup that really is equivalent to the Hydraulic Institute standard for diaphragm pump testing.
Yes. And to further explain our operating conditions here. Typically, a customer will have a certain set of conditions, say 100 gallons per minute, going against 30 psi of fluid pressure. So what we'll do is we'll adjust this throttling valve to achieve the 30 psi of fluid pressure. Then we'll lock the throttling valve so it doesn't move. We'll start up one pump, considering it as the baseline pump, run it by adjusting the air pressure and the throttling valve to achieve this certain condition of service, say 100 gallons per minute against 30 psi of fluid pressure. Once the pump has reached those conditions of service, we lock the throttling valve, record the data, which will be the fluid pressure, the SCFM, or the air volume that's being used, the gallons per minute, and the air pressure required to achieve that condition of service. We'll also count the number of strokes that it takes for that particular pump to achieve the condition of service. Once we have all that data, we'll shut the pump off and move to another pump. We'll put the air pressure onto that pump, and we will only adjust the air pressure to achieve the same gallons per minute against the same restriction. So the only variable that we're changing in this test setup is the air pressure or the air CFM going to the pump.
We believe this test is the most equivalent to what a customer is trying to do. A customer's got a piping system. He may have valves, he may have filters, he may have static head, dynamic head. But generally, when a customer interchanges one pump for another pump, he's not going to change that system. The loads that the pump is working against will be the same. And usually the customer has a specific flow requirement based on his process needs. So our objective here is to simulate the customer's piping loads and restrictions with the throttling valve. And then just as a customer would in his plant, he is going to adjust the air pressure, the air supply to the pump until he achieves the flow rate that his process requires. So we believe also that this is a real fair head-to-head test because each pump is putting out the same flow rate against the same pressure. So essentially, they're producing the same work output.
Yes.
So what we're doing is measuring the work input to the pump to gauge which one is the most efficient.
Yes.
Greg, I think we have a question.
We've got a question?
Greg, we're starting to get questions off the forum here. Would these conditions be similar to the effluents in the electroplating process or possibly beverage companies? Would these conditions be similar to a process you would use there?
Well, we're able to test the pumps at any variety of conditions. Diaphragm pumps are unique in that they have a wide performance envelope. They're inherently variable speed. They can run from essentially zero GPM flow rate all the way up to whatever their rated maximum would be. In the case of a 2-inch pump, it really varies by manufacturer, but between 150 and about 190 GPM. And certainly these pumps are widely used for both effluent transfer and in the beverage industry. So if we don't have any more questions, maybe we can get on with the live demonstration.
Sure, that would
Why don't
be
we
great.
start off with the Pro-Flo Shift, since that's what we're talking about here, and show people how it performs and what happens inside the pump.
Great. All we need right now is a condition of service.
I think for the purposes of our demonstration, we'll pick a typical condition of service, one that might be encountered in these industries we just talked about. We usually recommend that customers specify the pump in the center of the performance envelope. Of course, customers will use the pump all over its range, but for maximum reliability, we usually recommend to kind of shoot in the middle of the performance envelope for that pump. This would be a typical transfer application. So let's say 30 psi of head pressure, and let's say 75 gallons per minute for the flow rate.
All right. So all the pumps are valved off. We're going to start with the Pro-Flo Shift. And the valves are open, the air is connected, pressure traces are on.
So we'll start the pump up.
Yes, sir.
So we're gonna set our throttling valve until we achieve 30 psi at approximately 75 gallons per minute. I think we're right about 75 gallons per minute here on the flow meter output. You can see the gauge is peaking at right about 30 psi. What do you think?
Yeah, we're about 32.
So we're going to call that 32. Okay.
So
you can see that captured up on our chart here. As we get the information for the various pumps, we'll display them on the performance comparison chart above.
So we have 34 SCFM of air volume. We require
it's like about 51 psi of our operating pressure.
51 psi of air pressure. And the strokes we will count for 6 seconds and then multiply by 10. $110 strokes, roughly.
It's also interesting at this point to take a look at the pressure data inside the pump. You can see the characteristic Pro-Flo shift air profile in the chamber, where that overfilling at the end of the stroke is eliminated. And in fact, the pressure drops at the end of the stroke, indicating that you're getting some extra work out of that air without resupplying it.
Exactly.
So I think we've captured all the data here. One of the advantages of the Pro-Flo shift technology is there's no warm-up period or learning period. It just works straight out of the pump immediately every time.
Yeah.
So that's pretty much it.
Yep.
So if you want to shut down this pump, I think we can move on to the next one in the trial.
Okay. Which one would you like to try next?
I guess it really doesn't matter. Maybe we could try the Aero. I think this is an Aero EXP series model.
Yes.
Gentlemen, we have another question.
Oh, great.
Now, Greg, we see this new technology. We're getting some questions in the forum here. Can a user retrofit this technology, or do they have to simply buy a new pump?
Absolutely, you can retrofit the technology. We have what we call an air distribution system retrofit kit that will go from chamber to chamber for customers with our older technologies. If you have our more recent technologies, it even uses the same air chamber, so you can just replace the center assembly of the pump. However, the amount of savings that we've seen and calculated is so great that, in fact, if you were to just take a brand new pump, throw it out, and replace it with a Pro-Flo shift, it would pay for itself in just a matter of months. So really, the customer's got a lot of options open to them in terms of making these changes to realize the savings in an economically justifiable manner. So are we ready for the next pump here?
Yes.
Okay. Let's start it up and see what happens. So it looks like, without changing the throttling valve, we're going to leave that set for the whole test. This pump is putting out a little less performance at the exact same conditions. And this is one of the things I think that's typical of the Pro-Flo shift, is it's not just the most efficient pump in its class, but it's also one of the highest performing. So we're going to have to give this pump more air to do the same work and get it up to that 75 gallons per minute. I think we're there. You can see on the flow meter here, a little high, maybe 76.
We'll pull it down there. That should be good.
There we go, 75.
So we've got 75 gallons per minute of flow. We are requiring to do this, the Aero pump requires 47 SCFM and about 69 PSI of air pressure. and 130 strokes.
130 strokes. If you can show the pressure traces as well, it's interesting to see every pump has a different design, and you can see the ramp up in pressure at the end of the pumping stroke here, but it doesn't have that characteristic peak. Instead, it's a gradual ramp up. But again, that's extra air that's being put into that air chamber that's really not doing any additional work.
Agreed.
And if you cut back to the performance data, you can see there a dramatic difference. The aero pump there is using, in this particular performance point, it's using 38% more compressed air to do the same work. And that's one of the things, when I saw the performance data for the Pro-Flo Shift, I was really moved and excited by this technology. Usually you're working really hard to gain, a 5% advantage over the competition. If you're really lucky, maybe 7 or 10% advantage. And what we saw with the Pro-Flo Shift, just everywhere that we looked, was tremendous energy savings. So we believe this is really going to provide some value for our customers.
Absolutely.
So I don't know if you have another pump you want to test at this point?
Well, since we're over here, we might as well go to the Yamada.
Okay.
Gentlemen, we have another question.
All right, I'll take your question.
Now, Greg, one of the questions that's come off the board here is petrochemical processing. Will this be available in a plastic material option in the future?
We have the ability to build a plastic wetted path for the product contact surfaces now with the metal air distribution system, which this is how a number of manufacturers supply their pumps all the time. However, one of the characteristics of Wilden is that we offer a plastic air distribution system as well, which provides additional chemical compatibility for vapors or spillage or things like that. And we're working on the tooling to provide a plastic version as well, and we think that'll be available in about 9 months.
Okay, we're ready to go.
All right, let's start up the Yamada pump here. And this one's a little higher performing.
It's worth noting that the Yamada pump, right out of the gate, produces quite a bit more flow at the same pressure. So we're going to have to dial it back. That looks good.
I think we're there. 75 gallons per minute. Again, with the throttling valve untouched.
So to achieve that flow rate, again, of 75 gallons per minute across this constant restriction, the Yamada pump is going to require 52 SCFM of air volume and 40 PSI of air pressure. And 150 strokes.
And if you look at the pressure traces for this pump as well, you can see the characteristic increase in pressure at the end of the stroke, even as the pressure in the liquid chamber is decreasing.
Yes.
So once again, these traditional air distribution system pump technologies all perform in pretty much the same manner.
Yes.
All right, so going back to our performance data, you can see that the Yamada used even a bit more air than the aero pump. In fact, it used 53% more air than the Pro-Flo Shift. As you can imagine, that could add up to some pretty substantial savings if you have a lot of pumps in your factory.
Yes. Absolutely.
Greg, we have a question?
Yes.
Great question from the chat room. Will this be available worldwide?
Absolutely. This product will be available immediately from all of our distributors globally for pretty much every industry and every market.
Okay, next we're going to do the Versamatic traditional series, the Elimatic design.
Okay, ready to go?
Yes, sir.
All right. So we're going to lead a little more air here. we go.
And you can see on the pressure trace that the overfilling is really starting to present itself at the end of the stroke. And for the Versamatic to achieve this flow rate, again, of 75 gallons per minute across the constant restriction, it's going to require 55 SCFM of air volume and 50 psi of air pressure. And 160 strokes.
I think it's worth noting at this point the dramatic difference in stroke rate between the various technologies. Would you say that's that makes a big difference to customers?
I would think so. As we're all the pumps are going against the same conditions of service, you would think that the one that is stroking the most would have the least life.
Oh, so each stroke represents a flex cycle on the diaphragm?
That's correct.
So if it's doing more strokes to provide the same output, it's probably going to have a shorter life.
More flexing and a shorter life, yes.
And I guess that same principle would apply to the valve balls, the seats, and the air distribution system components as well.
Absolutely.
Okay, so it's interesting to note there, we've captured on the top row the strokes per minute of the various models in this condition. You can see a pretty dramatic difference. So not only is the Pro-Flo Shift outperforming them in terms of the energy consumption, but it also has the least number of strokes per minute to accomplish this amount of work.
Greg, we have a question.
Yes.
Greg, from the chat room, we have a question. For competitive technologies or competitive AOD pumps, would this system be retrofittable to an existing application, and what would that retrofit process be?
For certain models, we have retrofittability available today, particularly certain Versamatic models where they're similar enough to the Wilden models that our components will interchange into their pumps. We're actively developing retrofit kits for other technologies as well. And as I mentioned before, you've always got the option to replace the complete pump. Most of these products provide interchangeability to the customers in terms of the location of the discharge and inlet connections. So it's a very simple matter to swap one out and interchange it for another. And the savings provided by the technology really makes that affordable, with sometimes only maybe 3 or 4 months return on investment for the purchase of an entire new pump.
Okay, I believe we're ready. Next on the list is going to be the Graco.
Okay, so we're going to test the Graco pump. I think it's going to need a little bit more air.
Yes, sir. All right,
Okay,
again.
you can see the 75 gallons per minute there.
Perfect. 75 gallons per minute against the constant restriction. And to do that, the Graco is going to require 50, we'll call it 53 SCFM. Mr. Duncan, what is the air pressure?
Air pressure looks like about 66 psi.
66 psi. And 150 strokes.
Can we take a look at the pressure traces as well for this model? You can really see on this one, it even spikes up a little bit at the end of the stroke.
Yes.
As that overfilling occurs in these traditional designs.
Great.
Okay?
Yes. So it's worth noting that we are operating in a condition that's basically right in the middle of the curve. As you move to the right of the curve, this overfilling phenomena that takes place is actually more prevalent.
But really, the right of the curve is where the pump's using the most energy as well.
That's right. So it is the least efficient least efficient way to operate the pump, and basically the pump does not react quick enough to release all that energy that's built up in it. So we wind up with overfilling.
So in essence, this phenomena, this overfilling phenomena that we're taking advantage of with the Pro-Flo Shift to make a better pump, the phenomena is the worst, or the opportunity is the greatest, right at the point where the pump is using the most energy.
Yes.
So you get the most benefit right where you need it.
That's correct. But as we run to the left of the curve, we still see significant savings.
Greg, we have a question from the forum.
Yes.
Greg, Kevin John Parker wants to know, is there a particular industry that's worldwide where you think the Pro-Flo Shift will make the largest immediate impact?
I think one of the industries where air-operated pumps are the most prevalent is in the paints and coatings industry. A lot of these process fluids have suspended solids and characteristics where they will harden or settle, where they have to be recirculated continuously. So these customers have a lot of pumps, and the pumps are on 24 hours a day, 7 days a week to prevent damage to the process fluid. So these guys really stand to save some substantial energy costs from the adoption of this new technology. Of course, there are many other areas where you see a benefit as well, from dewatering in mines. They see extensive use in the sanitary industry and the pharmaceutical industry, as well as general chemical and petrochemical.
Okay, the next pump up is going to be the traditional sandpiper design.
Okay, we'll start that one up. There we go. So you can see 75 gallons per minute here on the flow meter.
Again, 75 gallons per minute across the constant restriction. For sandpiper to achieve this flow rate, they require 53 SCFM.
And the pressure to do this job is right at 60 psi.
60 psi?
That's right.
60 psi. And to do the flow rate, they require 200 strokes.
Okay. You can see the pressure curve there. Sorry, I was a little fast on the valve. And again, you can see the traditional overfilling.
Yes. The air continuously rises throughout each stroke.
Carl, while we're on the subject, this is a good example. You can see that the liquid pressure is kind of bouncing up and down. It's not as smooth as the air pressure. I was wondering if you had any ideas as to why that happens.
I'm sorry, I didn't...
I was wondering if you have any ideas as to why the pressure is bouncing up and down on the liquid side of the pump.
Well, we like to think that it has two components. Either it's ball chatter, the balls are trying to come down and seat properly, or there could be some hydraulic instability trying to pull the fluid into the pump.
Okay. So again, you've seen some pretty dramatic savings here. I think the Warren Rupp pump uses 56% more energy than the Pro-Flo Shift. So across the board, just huge opportunities for savings. But I think it's worth noting, these pumps are the traditional technologies. There's thousands of them, probably hundreds of thousands of them out in factories across the globe today. But we also have, of course, we're not the only ones developing new technology, and we have some advancements from our competition that are really targeted at the objective of saving energy. And in particular, what we've got here today is the Air Vantage technology from IDEX. They make this available for a couple of different brands within their product arsenal. The Sandpiper or Warren Rupp brand, and also the Versamatic brand, and we're fortunate to have both models here today. So we can show you that even with these, I don't know, maybe you want to call them more advanced technologies in terms of energy consumption, the Pro-Flo Shift still provides a definitive advantage.
Greg, you know, I get a lot of questions on whether the Pro-Flo Shift, whether you lose performance or flow rate with the more advanced technologies.
You know, that's a great question because the AirVantage technologies and some similar technologies do give you an advantage in terms of efficiency, but a lot of times that sacrifices the performance or the flow rate of the pump. And we worked really hard to optimize the balance between flow and efficiency on the Pro-Flo Shift so that you really don't lose much performance in exchange for the tremendous energy gains that you get.
So we're ready to go. How this design is supposed to be run is you leave the air advantage off, we start the pump up, we achieve the condition of service, and then we turn the technology on. It will basically go through about a 35 to 40 second learning curve where there's a light indicator on the unit that will be blinking fast. Once the light blinks slow, you'll actually see in the pressure trace towards the end of the curve where it starts to drop off. And then the learning process will continue until the light blinks in sync with the air exhaust. Once that takes place, then it's at its optimal condition.
Carl, I think it's worth noting here, one of the characteristics, a key characteristic of air-operated diaphragm pumps is the fact that they don't use any electricity. It makes them extremely portable, extremely cost-effective to hook up and disconnect. You don't need an electrician or conduit or breaker boxes or things like that. And it makes it very well suited for use in explosion zones. So what we have here with this AirVantage technology is really introducing electricity and also a computer onto the traditional air-powered pump. So essentially what this computer does is monitor the pump and attempt to actively intervene in the pump's operation to reduce its energy consumption.
Yes, so they have a sensor that basically is attached to the pump's inner pistons, so it will monitor the speed and the position of the pump diaphragm, and then send that signal to a microprocessor, which basically tries to inject a certain amount of air to complete the stroke with the minimal amount of air required. With that said, though, some of the compressed air that enters the pump is actually diverted down to a turbine that will generate the electricity. So it has on board its own electrical power plant.
Which is kind of an interesting technology, but I guess what you're saying as well is there's an energy cost associated with this technology that to an extent offsets some of the gains that you receive.
Yes, while it's learning, it will actually still be driving that turbine, so it is wasting a certain amount of compressed air to generate the electricity.
Well, let's start this pump up and see how it performs.
So again, we'll start in the off condition. And we have a light indicator right here. It's worth noting that we switched from one pump to the other pump, basically the same pump. And as you can see, our gallons per minute's down a little bit, so we have to increase the air pressure to get the flow back up. So the extra energy that is being used to generate electricity wasn't being used before. So our flow rate actually came down a little bit.
And at this point, the AirVantage technology is not activated.
That's correct.
You can see here on the pressure traces what's going on inside the pump. And you can really see the end of stroke of the pump there with the drop-off in liquid pressure. And you can see that spike in the pressure in the air chamber, which is the characteristic overfilling.
Yes, what you'll see in traditional diaphragm pumps is we just have a pilot valve that sends the signal to the air valve. So there's really only two components that are reacting. In this pump, we have the pilot valve sending the signal to the air valve, but there's also a solenoid valve and a check valve / modulation valve. So there's a few more components that have to react, and you can see the overfilling that's taking place because of it.
So let's turn this technology on and see if it can make a difference in the overfilling.
Okay, so we turn the light on, and the light goes solid green first.
So So the solid green light indicates that it's working?
Yeah, basically we're energizing everything, getting the components ready to go.
Oh, so it's charging up, but it's not actually saving any energy at this point.
You could think of it in that direction.
Okay.
And now it's blinking fast, so now the pump is actually monitoring or learning how much air it has to inject per stroke.
So is it saving any energy at this point?
Not at this point.
So now it's
as you can see from the SCFM.
it's just learning. Oh, and I guess you can see on the chart as well.
So it has slipped into the air advantage mode.
Okay.
And the air is starting to cut off at the end of the stroke.
So you can see as this unit starts to learn and activate, the pressure in the air chamber, the pressure profile actually starts to change. And that overfilling is reduced.
So the light is not blinking in sync with the air exhaust, so it's still not at its optimal condition, but it is at least giving us some energy savings, as you can see on the pressure trace.
So right out of the gate, once it has learned, it starts to give you some savings, but it continues to optimize itself for a period of time?
That's correct. So once
looks like it's still not optimized yet. How long does that typically take?
It varies depending on the conditions of service. The best I've seen is about 30 seconds. The worst has been about 10 minutes.
Okay.
And it's probably worth noting at this point that our flow rate has dropped off down to, it's about 73, 74, so not too bad.
But essentially, if you're trying to achieve a given flow rate, and you set the pump to do that, this technology can, in a sense, interfere with that, and you have to readjust the pump to compensate for it.
Yes. Either you readjust at the beginning so you get more flow in its learning phase, so once it does learn, hopefully it's hitting the point that you want, or you have to readjust the pressure after it's learned to get you the flow that you're looking for.
So let's give it a little more air. For a fair comparison, I think we want all of these pumps to be doing the same work.
That's correct.
And I think we're there now. It looks like about 75 gallons per minute on the flow meter.
And the light still is not blinking in sync with the air exhaust, so we're still not at the optimal condition. The pressure traces do show a telling story. They are continuously changing their profile.
You can actually see that it seems like the overfilling's been further reduced as it's learning.
Yes, so they are, as you can see from the peak, injecting quite a bit of air at the beginning of the stroke, and then basically shutting off the air or very, very restricting the airflow to let all that energy that's in there finish the stroke out. We're still not quite there.
Have there ever been instances in your testing where it never did quite figure it out all the way?
No, eventually it does take place.
Okay.
And it's worth noting that we have dropped off.
Oh, I think it's there.
We've dropped off significantly. Yes, it is at its optimal.
So when it's optimal, the light flashes in sequence with the pump stroke.
Yes.
Okay.
But you can see from the gallons per minute now have dropped off to 69.
Oh, wow.
We were trying to hold 75.
And we had already adjusted it once.
Yes.
So you're looking at almost a 10% reduction in performance.
Yes.
So really, if you were just looking at the air consumption at this point, you might be misled thinking the savings is bigger than it really is.
Right.
Because the pump is doing less work.
Yes.
So we're gonna readjust it here to get back up to the same flow rate. A little too much. There we go. That seems pretty good. And it's still synchronized.
Yes, the light is still blinking. So I would say this is
time to capture the data?
Yes.
All right.
All right, so For the Air Advantage to hit 75 gallons per minute against our constant restriction, they require 47 SCFM and about 88 pounds of air pressure. And 190 strokes.
So you can see on our comparison chart, the Air Advantage did make a pretty big difference in the efficiency of the traditional Warren Rupp pump, but it's still using 38% more air than the Pro-Flo Shift, and it's also using a lot more strokes per minute to accomplish that performance.
Yes, the Air Advantage sandpiper requires about 15% less energy versus their traditional design.
Okay. Well, I think it's important to note, however, that this is a pretty costly technology, isn't it?
Yeah, from what I understand, it's about $1,200 for list price.
That's for the whole pump?
No, just for the addition, just for the technology.
So for
on.
the same pump, if you want to add this technology on, it's roughly a $1,200 increase?
Yes.
And it looks like there's a lot of components and complexity that you're adding to the pump as well.
Yes, I would agree. Personally, I think it is a cool technology. However, I'm not quite sure for the air diaphragm pump.
Maybe a lot of cost and a lot of complexity to not really achieve that much savings.
Yeah. Since we're on the Air Advantage, now we'll slip over to the Versamatic Air Advantage.
Greg.
Yes.
We get a lot of questions about batching process, because you'll find air-operated double diaphragm pumps that are used in batching applications.
Of course, it's a very typical process pump.
How would the Air Advantage play to a batching application?
Well, one of the challenges with these types of technologies is that there is this learning period. And as you observed, there's a pretty significant difference in flow rate between operation prior to learning and then the operation once it's fully optimized. So it's a little bit difficult to set your pump to achieve the desired performance because it's in a batching operation, the pump is turning on and then turning off. And so it's constantly cycling between this learning and unlearned modes. In addition, before it's learned, you're actually using more energy than you would with a traditional pump because of the energy costs, the energy consumption of the technology. So there's also a period of time, of course, maybe 2 or 3 or 4 minutes in each process where this is taking place. So if your process is only 5 or 10 minutes long, there may be really no value to this technology. I'd say it's maybe more suited to steady state operation.
We're all set. Next is the Versamatic Air Advantage.
Okay, let's start this one up.
Again, we're starting in the off mode, or a traditional design.
Okay, I think we've got it set at it's about 75 gallons per minute here.
Okay, now we'll turn it on. And the light is solid green, so we are energizing it. And now it's blinking fast, so it's in its learning mode. There we go. Now it is learned, and now it's starting to take advantage and try and inject the proper amount of air. When the light is in sync with the air exhaust, it has optimized its condition.
And you can see a pretty dramatic difference there in the pressure in the air chamber.
Yes,
It basically eliminated that overfilling condition.
It almost looks exactly like the Pro-Flo Shift.
Is it fully optimized at this point?
Not yet. There we go. So now the light is blinking.
And we lost a little bit of flow here, not quite as much as before, but we're going to have to adjust the air pressure to compensate for that. Okay, I think we're pretty much there at about 75 gallons per minute.
Okay.
Is it still synchronized?
The light is still blinking in sync with the exhaust.
Okay, great.
So we're at
So we
the
can capture our
optimal,
data.
and we're ready to capture the data. So we're at about
Looks like about 46 psi.
46 pounds of pressure and 39 SCFM. (130 strokes).
So of the competitive technologies, to really gain a substantial savings, you have to move to kind of this AirVantage, but there's a pretty high cost associated with that.
Yes.
What about this issue of introducing electricity to the pump? Can this unit here be used in an explosion zone?
Well, as you pointed out before, one of the advantages of an air diaphragm pump is not requiring electricity. So in an explosion zone, the air diaphragm pump is really a wise choice. Starting to introduce electricity into that atmosphere can cause problems. And however, AirVantage does have a explosion-proof design.
So not this standard design, but they have an optional model that's rated for use in explosion
Yes,
zones?
it's ATEX rated, and it's still aluminum in its construction, so if there's anything foul in the atmosphere, there might be some problems with corrosion.
Oh, okay. What about the cost difference? Is it the same price? You just have to choose the version you want?
No, I believe it's a substantial adder. Somewhere around 2,000 from what I understand.
So the cost increase for this technology almost doubles if you need to use it in an explosion zone.
Yeah.
Which is really a typical application for these types of technologies.
Yes, and it's
good to know.
It's worth pointing out one of the greatest applications for an air diaphragm pump is submersible, and obviously now that there is an electricity component to this unit, you really can't submerge this design.
Okay.
Would we like to try the traditional PX?
Sure, let's go ahead. We've got it on our skid here. This is Wilden's current technology, the Pro-Flo X design. And we may as well see how this Pro-Flo X stacks up to the competitors and also to the Shift.
Greg, we have a question on hygienic. Will the Pro-Flo Shift be available for hygienic applications, and how do you see the Shift working in hygienic industries?
I think it's very well suited to hygienic industries, as is the current Wilden offering. There's some nice capabilities about the air-operated pump technology that makes it well suited to hygienic industries. There's a very low rate of speed differential between the moving parts and the static parts in a diaphragm pump. If you think about other pump technologies where you have rotating components, you've got a high-speed component moving against a static component. And what you can get is when the process fluid is in there, you can get abrasion. And even though they specify and build these pumps with really, really great surface finishes for cleanability, after a few weeks of operation, essentially that surface finish is scored and marred simply by abrasion with the process fluid. Diaphragm pumps, due to their inherently low internal velocities of the moving parts, you have much less abrasion with the housing. And you also have less velocity of the process fluids, so you maintain that cleanable surface finish a lot longer. You also eliminate an Achilles heel of a lot of sanitary applications, which of course is the rotating shaft seal. Diaphragm pumps are inherently sealless, So this very difficult to maintain and costly component is completely eliminated. And this is also a component that's very difficult to keep clean and sanitary.
And Wilden will be offering Pro-Flo Shift.
Absolutely. We're gonna offer the Pro-Flo Shift technology in both our traditional FDA cast stainless steel versions and our fabricated and polished hygienic series pumps.
Okay, we're all set. The next design and final design is Wilden's current PX.
All right, let's see what the PX technology can do. Now this is what we would call a traditional technology.
Yes.
And just like the others that we saw today, you can see kind of on the pressure traces there, this overfilling that happens at the end of the stroke.
Yes. And we're a little bit shy on pressure, so we're going to have to bump that up.
Okay, I think we're right at about 75 gallons per minute on the flow meter here.
Yep.
Now, the nice thing about the Pro-Flo X and, of course, the Pro-Flo Shift is there's no learning phase. So we're basically ready to go right now and capture these numbers.
Yeah.
Okay.
So for 75 gallons per minute against our constant restriction, the Pro-Flo X is going to require 38 CFM.
And it looks like the operating pressure to do that is right at 48 PSI.
48 pounds of air pressure. And 110 stroke.
Great. So you can see the data here, somewhat interesting. Those of you that know Wilden, this probably comes as no surprise. But our current technology, the Pro-Flo X, is already the most efficient technology out there on the market. And in fact, not only does it provide efficiency, it's also one of the highest performing technologies, and the least number of cycles per minute suggests that it has greater component longevity as well. The Pro-Flo Shift merely increases that trend, putting further distance between us and the competition with basically the Pro-Flo X using 12% more energy than the Pro-Flo Shift.
Yes, and worth noting that when you get into plants that have literally multiple hundreds of pumps, this technology can help save enough energy where I would not be surprised if they're actually turning off air compressors.
Oh, that's great. One thing that really is difficult to be replaced is to see this demonstration in person. When you see it with your own eyes, you know, you don't doubt it, like maybe you would doubt a piece of paper or something on the internet. And we felt that bringing this to you live like this was the next best thing to being here in person. But I certainly want to extend to every one of our viewers the opportunity to come by the Wilden factory. Our factory is always open to you. We'd be happy to tour you around, and we can show you this in person. So if you're ever in the Southern California area, we invite you to stop by.
Greg, we have one more question.
Okay.
From the chat forum, we have a question on how long the Pro-Flo Shift was in development, and was there a eureka moment when you knew you had something special on your hands?
That's a great question. Carl over here was developing the Pro-Flo Shift for quite a number of years.
Yes.
And I can't speak for his eureka moment, but I can tell you when he actually presented the concept, the finished concept to me, it certainly was a eureka moment to me. The simplicity of the design and how it works is just like a light bulb goes off when you see it. There's a lot of things in our lives that are very complicated, computers and cell phones and all this state-of-the-art technology, and it does very interesting things, but when you look at it, you realize you probably aren't really going to understand what's going on under the hood or inside the product. And when I saw this product, I didn't just see the performance, I also saw the simplicity and immediately understood how it worked. And I think that's one of the real geniuses of this design, is you're able to accomplish so much in such a simple way. So Carl, I don't know if you had any light bulbs go off during the development yourself. Maybe you could speak to that.
No, while I had been developing this thing, I've learned quite a bit. However, I must say that the engineering department did an incredible job of taking a simple idea and making it actually simple for the customer to use. So personally, I think that's a eureka moment.
Great.
Well, as we wind down this live demonstration, as you can see, we're very passionate about innovation, very passionate about air-operated double diaphragm pumps. And it's our mission to continue to move the industry forward with such innovative products such as Pro-Flo Shift. The proof is in the pump. We encourage you to visit profloshift.com to see many videos and articles and white papers on this technology. We thank you for attending the Wilden webinar on Pro-Flo Shift. Thank you for your time.